Hey everyone, so here we'll be solving a beautiful problem container with most water. This is also one of very good lead code problems. So let's see what it says. You can read the problem statement. It is said that you will be given an array, and what that array represent, it represent height. Every element represents height, some vertical heights drawn on x-axis. All right, on x-axis, some heights are drawn. What are these heights? The values in that array, and you have to find the you have to give the area of the maximum water that someone can trap, that some height can trap. All right, let's see the question, like this test case what is given. So consider, see guys here. So this is your height, this is your given height. If you see 186,254 and also and so these are heights. All right, this is your x-axis, this is your x-axis here down the line, and this is your height. Now see guys, in a simple, if I have to give you a simple thing, so like I have to ask you a simple thing. Just give me this thing that if you're having, let's say, this height and this height. All right, let's say 2 height and 5 height. So, and the width between them is, let's consider 3 as of now. I want to get the, let's say I'm putting in water, I'm putting in water here. See, this is one height and this is another height. All right, I'm putting some water here. So what would, see, obviously the area, so I'm just asking what would be the area, or what would be the water that will be put, like that will be here. All right, that will be, see, first of all guys, it's not volume, it's not in 3D, it's not in three-dimensional, so we are not going for volume, just a 2D pictorial representation. In 2D, how much water can you think? How much water if I put here? How much water if I put here? You think that how much water can it store? Obviously, the area, you have to find the area. All right. So that will be what? And you know, area of rectangle is what? Because this will be forming a rectangle. And what is the area of rectangle? Area of rectangle is length into breadth. All right. Or length here you can call it height. See, breadth or width, whatever you say, it is 3. It is 3 unit. That is fixed. But here you are having two heights, 2 or 5. So which height you will use? Which height you will use? A minimum one. All right. If you put water, so after this it will spill out. All right. So 2 is the maximum height which you can fill for this water. So what you will calculate, the area you will calculate as, let's say, you can calculate the width or breadth multiply by minimum height of, let's say, left or right height, or higher height, lower and higher height, the minimum of these two heights, like L and H, or left and right, whatever height you can see. So width multiply by minimum height. So this is what the area will give you, like how we'll calculate the area for the trapped water. All right, so let's see this problem, how to solve this. So in brute force, what you can do guys, in brute force, for every index, let's say for every element, you'll go to its right and you will try to find, see, if you'll go to right, let's say this much index, you went to this much index. All right, so you will see that, because what I'm saying is, for this height I'm seeing what is the maximum area, what is the maximum area that I can trap. So obviously, so it will only trap, so some other index to its right, to some other index to right of this index, it will only trap water if the height is greater than equal to this. If in its right, the height is greater than equals to this. All right, so you'll keep going forward, and till what, like you will just see that if you are getting greater height, you'll calculate what, you'll calculate the width, width. How will you calculate that width? Simply this index minus this index, the width, let's say it is what, 0 1 2 3 4 5, 5 minus 0, 5 unit of width, multiply by this height. All right, so in this way, for every height you will go in the right direction, you will go in right direction and calculate the width by the same similar formula. As you guys can guess, the complexity, obviously, because one loop, like outer for loop, inner for loop, so the complexity will be order of n square. All right, so we can do something better. Obviously we can do something better, but let's observe how we can go for optimized solution, because order of n square we will avoid that. All right, first of all, I hope you got this idea about brute force. Do let me know in comments if you got this idea of brute force. All right, come on, let's see this. So initially what I'm saying guys, if you were given this height, let's say this height, like this is the maximum. All right, because what we know, how we calculate the area, it is the width multiply by some height, I'm not going in that way, that minimum of height. We know that we have to calculate the minimum of two bounds, lower and higher bound. But what I'm saying, width cross height. So Height is variable here. Like height is something that we don't know. We have to go from, we have to get that from array. Height is something that we have to get from array, and it is variable for every index. We don't know. But for width, we can see this hint, see this idea that let us see for the maximum width. All right, let us see for the maximum, which is this width. Final index minus 0, or I can say final index minus this index. So the maximum width, this is the maximum width. So because we have to calculate the maximum, in this way we have to calculate the maximum area of, or maximum water that can be trapped. All right, we have to calculate the maximum, this maximum area. So to calculate the maximum area, we don't know about h. We have to get that from array. But what we know for sure, we know that width. So let's increase, because to calculate, to get the maximum area, what we can think in a way that if I can maximize the width, so the maximum width is this much, initial index, this index, till final index. Now let us see. So we can start, let's say, so here you got this idea. First of all, the first thing is, at least you are you getting this hint or not for 2-pointer? Why? Because to get the area, to get the area maximum area. All right, so at first what we can think, that let us consider the entire width. Let us consider the entire width, which means the initial index, let's keep it here L, let's keep it here H. Let me write the this indexes for them, so it will be easier for you guys. So h will be at 8 and this will be at 0, L will be at 0. So what I say, see guys, what I say here, that let me write it, h and L. All right, 0 and 8. So what is the width we are getting? 8 minus 0, the width is 8, the width is 8 unit. But if you see guys, in this area, if in this width, in this width, in this width, these two are the bounds, these two are the heights that you are getting. So who will decide the height? Who will decide the height right now? If you guys consider, if you guys remember the previous thing, what I said, the minimum of two heights, minimum of two heights. All right, so this height, if you try to fill in this width, in this entire width, look, the width you got, width is 8 minus 0. All right, but what is the height that up to which you can put in water? If you consider this width, obviously after this width, water will spill out. So this is the maximum height. Sorry, after this height, water will spill out. So this is the maximum height. So you will draw this. All right, so this is the height. So in this way, what you know, first of all, h minus. So how will you calculate the maximum like how will you calculate area at certain level? H minus L, this is your width, which is it, this multiply by minimum of what, let's say this height, this is height array, right? Height array, height of h, minimum of height of h comma height of L. All right, so this is what, this is how you have to do first of all. Now let us see guys, how will we, like, because here we don't, here we have not got the maximum area, and we will also keep a variable which is, let's say, max area, which will update. We'll find the possible maximum areas, the possible area, the areas that can contribute, like that can uh, like maximize your area. We'll calculate that. We will keep on calculating the areas, and we will update this max area variable. So right now you got this. Initially what you got, from this index to final index. All right, from this index to final index. Now let's see guys, this was wait, I'll again write this 0 1 2 3 4 5 6 7 and 8. So initially you went for the maximum width. Now see, after, obviously, so you are done with 8 minus 0, 8 width. You are done with 8 width. Now what width you can calculate? Possibly, because if you keep see, if you keep the width maximum, there's a chance that you will obviously get maximum area. Just keep a width, because height you are not, like, you don't know, this is not in your control. This is in this array, we have to see every time. But let us try to maximize the width. So for 8 possible width, like for the maximum width you calculated, let's say your answer. Now the width would be 7. Now the width will be 7 unit, because you have to decrease it one. See, you have to keep the maximum width, but obviously for 8 you got your answer. So after 8, which is the maximum width? Obviously 7. So let's see for 7. But wait, what we can do, which is what is the bound? See, if you see these two bounds, between these two bounds the width was 8. इनके बीच में 8 की width थी, which we already calculated. So obviously now these two won't be the bounds, the lower height and higher height. So we have to like remove one of it. Either we have to calculate, see what I'm saying guys, just be with me and you will get everything. What I'm saying is, So initially we calculated height, sorry, area with this much, this bounds. Right now we, as we want 7, so we either I have to exclude this or I have to exclude this. All right. So either I'll go with this width or I'll go with this width. All right. Now let us see who decides this and how will we decide this. So this is one more remaining part. Otherwise, this solution is pretty simple and it is done. So what I say, guys, see, wait. I'll also remove this. What I say here, see, guys. So initially, what you got, this height with this height, which means the index number 0 and index number 8 height you got. All right. You calculated the area. You calculated the area that you can get with 8 width. Now you want with 7 width. What I say, because we want, either we will do L plus plus, either which means we will ignore this, so we will get from this, or we will do H minus minus, which means we will ignore this and go to this. What we do, L plus plus or H minus minus, who decides this? Let us see that. So this height, see guys, this height, let me change my pen. So this height was lesser than this height. All right, if you can see, this height was lesser than this height. So as I said earlier, remember guys, because width is in our control, width is in our control, height is not directly. We have to look at every step, what is the height. Now see, what we tried initially, we tried to maximize the width. That is why we took 8, then 7, then 6. All right. Now by maximizing width, if we can also maximize height, then this combination, maximum width, maximum height, this will surely give me what? Maximum area. Think in this way, guys. This will surely give me maximum area. So see, who is having the bigger height? This one or this one? 0th index or 8th index? Obviously 8th index. So as I said, see, we have to get the maximum width. So after 8, what is the maximum width? 7. Then we will think that, yeah, I got the 7 width, which is the maximum. Now let's see the maximum height. I also want, if I can get the maximum height, then the combination of it will surely yield me what? Maximum area. So now just pause this video and think of it and let me know in comments right now that with 7 height, what will you do? And as this lower height was lesser, so will you ignore this height? No, you cannot ignore this higher height. Like so because 0 and 8 index, see guys, 0 and 8 index, 0 index height was lesser, and we saw that because we have this like we can control the width, and we are maximizing it. Let us maximize the height as well. So if you ignore 8 height, which is of maximum height, which is greater than this, so you want to get the maximum height. So that is why we will ignore the lesser height. So what it means, see guys, so you will ignore the lesser height. You will now calculate the area for this width. I hope you got this idea, guys. So what I'll say, if I have to write this in loop, sorry, if I have to write this condition for because see, L and H, they're starting from final indexes, and we know this is a 2-pointer approach. So what we have to check, where we have to move, L plus plus or H minus minus. So what I say, if let's say height of L, you saw this, height of L is, if it is lesser than what? Height of H. If it is lesser than height of H, which means this height was lesser, so you have to ignore this. You should ignore this because we want the maximum, we want the greater height, so we will keep this height. So in this case, what we will do, L plus plus, else H minus minus. All right. So the way to write this condition can be different. Like you can include equal to as well, no problem in that. But a simple idea would be like this: you have to keep the maximum height. You have to ignore the smaller height of these two bounds. So I hope you got this idea, yeah, that how we are going. And in this way, guys, see, in this way, L and H, if you can guess the next steps, L and H, they will move towards each other. Until what point they will move? L should be less than H only. Why? See guys, because to get area, you need at least two heights, right? You need at least two heights. Now L equals to H. If this is a condition, which means both L and H are at same index, which means there is only one height remaining. Because see, L and H, they give you what? They give you a search space. All right, this is how, if in 2-pointer, in binary search, everywhere we saw L and H will give you your search space. Now see, we want that at least there should be two elements in search space. We want that at least two elements should be in search space. Why? Because an area will be enclosed by two heights. by two heights. If you're not having two heights, if you're only having one element, there is no area. All right. So because just this five height, how much area you can trap? You cannot trap anything, because if you put water here, it will spill in this ground. So you need two height. So if L is equals to H, which means that there between L and H, how many elements are there? L equals to H means L and H are at same index, which means there is there is only one element. So you cannot go for L equals to H even. And obviously when L is greater than H, you have exceeded your search space, you have exhausted your search space. So till what point you will keep on searching? L less than H. L less than H. All right, are you getting it or not? कि भाई L equals to H तक क्यों नहीं खींच पा रही हूँ? L less than equals to H क्यों नहीं किया? Because L equals to H पे एक ही हाइट बचेगी तुम्हारे पास. Now let's see the solution. Now that's the solution that I have. This is height, this is lower bound, higher bound, like higher index. Maximum area variable, I hope you guys can relate with this, that we will be updating this maximum area at every step. Not this thing that I told you. Starting like L is less than H, this thing we'll keep. At every step we'll get the maximum area. Now what is this? Maximum of whatever maximum area we have till now, multiply by minimum of the heights, minimum of the heights, multiply by that of H minus L, the width. See, width we know, and height we have to get the minimum of the corner heights that we are having. And see here how like I explained earlier, that if your lower height is lesser, which means because see, as I said, height into width, we know we are maximizing this width. Yeah, early, like we have this idea for the maximum width. Earlier it was 8. Now we will go for 7 width. We will not go for 5 or 4 width, because we want to keep this. Look, we cannot go higher width, because after 8 there is no width. After 8, if you see here, after 8 you cannot go to right, there is no width. So we are decreasing width, we have to decrease width, but make sure that we will decrease width in a way that whatever width right now is the maximum. So after 8, which is the maximum width, 7. So after 7, which is 6. So in this way, for the width we are having control, but for height we don't have directly. And that is why we are saying that we will do L plus plus or H minus minus in a way that we will keep the greater height. And if the lower height, see, if the L height is lesser, if the height at L is lesser, we know that we will ignore that L, we will go L plus plus. If this is smaller, L was here, we know that we will go L here, because we don't want to lose this height. This height is greater. And if in else block, we will do that H minus minus, and finally we'll return maximum area. So guys, do let me know in comments that you got this solution, you got approach, you got the intuition, you got why we are doing this L plus plus H minus minus, and why we are doing, like, why we are not going for L less than equals to H this time. Let me know in comments. चलो मिलते हैं बाद में.